Let's get started for the topics on homework number 30. The first topic is conversions with dimensional analysis, or changing from one rate to another. So in this question, it states that the water flows through a pipe at a rate of 8,600 cubic meters per hour. They ask you to express this rate, or flow, in quarts per second and then round your answer to the nearest whole number. This reference chart down here will be provided for every question, and there will also be a reference chart like this on your Regents exam. So the first question starts with 8,600 cubic meters per hour. So we're going to start by setting up our first ratio. So that's cubic meters per 1 hour. Now the trick to converting units from one measure to another, and I'm just kind of estimating the length here, is to write your original units and write the units you want in the end. Now one is a measurement in quarts and one is a measurement in time as seconds, and you're going to change these measurements separately. So for most of us, time is the easiest conversion because we don't need to look that up in a chart typically. So I'm going to start with converting my hours. So I need to think of some information I know about hours that can get me to information about seconds. And some people know how many seconds are in an hour. Well, let's say you don't. Then you can start off by saying that I know that 1 hour is 60 minutes. And I'm writing my ratio here. I'm writing mine as hours over 60 minutes. But this is also acceptable because it's the same comparison of numbers. Now how you choose to write your ratio depends on where you're trying to eliminate the value. So for us, hours was located in the denominator. So if I want to cancel hours, it needs to be located in the numerator. So for every 1 hour, I have 60 minutes. I'm actually going to make this a little bit smaller so I have more room for my other rates. So I have 1 hour is 60 minutes. So I know that my hours are gone, but I still have minutes and I need to get to seconds. So I'm going to come up with another rate. Let's see. I know I need minutes to cancel out. So I know in 1 minute there are 60 seconds. So there's my cancellation, and my seconds are a match. So I no longer need to multiply by any ratios, by any fractions that have to do with time. Now I have to figure out how I can convert my cubic meters to quarts. So I'm going to go back to my reference chart here, and let's take a look at what we have. So I have to look for information about cubic meters. That's what I'm looking for. Information about cubic meters. Let's see over here. I see 1 cubic meter is 1,000 liters. And that's the only thing I see about cubic meters. So this is definitely a ratio that I'm going to need. So a cubic meter, 1 cubic meter is equal to 1,000 liters. I could also write it like this. Right? This is the ratio that I'm getting from my reference chart, and these are the two ways in which I could use it. Now remember, you have to use it in such a way that it will cancel both in the numerator and denominator. So let's go back to our chart here, and I'm going to use green this time, and I have cubic meters in the numerator. So that means I need cubic meters in the denominator. So that was 1 cubic meter makes 1,000 liters. So I got that cancellation here, cubic meters, cubic meters. So now I have liters per second. But I don't want liters, I want quarts. So I got to go back to my reference sheet and see if I can find another ratio in which I can get liters to cancel out, right? That's the goal. I need some type of conversion that has liters in it. Hopefully it will get me to quarts. got to take a look here. I have down here at the bottom, I see I have 1 gallon and this many liters. Ooh, and then I also see liters here, but I'm not interested in milliliters. And there's the word quarts. You see that connection? I can go from liters to gallons, and then I can go from gallons to quarts. So these are the two ratios that I'm really interested in using. So I want to use 1 gallon is 3.875 liters. 1 gallon is 3.785 liters. So let's go back here. One gallon. To move this over. 3.785 liters. Shorten this up a bit. And that gives me a liters, canceling liters. And now I have one more ratio to go grab from over here, and that is this one here. 1 gallon is 4 quarts. So 1 gallon is 4 quarts. And there's my final cancellation. So everything should have a cross out except what I want. Yep, seconds and quarts. That's perfect. So I actually don't need this here. That was just my goal, right? That was just where I wanted to get. Okay, so I'm going to take away this circle here just so it's not as crowded. Oops, sorry. And I'll take away this circle here. All right, now all we're left to do is compute all of this math. So I'm going to bring my calculator up over here. Let's see, I'm going to bring it down here so you can see the screen. And I'm going to type 8,600 times 1 times 1 times 1,000 times 1 times 4. Right? That's a lot of math to type, but I'm just going to make a giant fraction here so that it looks exactly on my screen how it looks on my paper. So 8,600. I'm going to skip the times by 1 because we know that doesn't really do anything. So times by 1,000, times by 1, and then times by 4. Okay, now down in my numerator, it looks like I have 1 times 60 times 60 times 1 times 3.785. So I'm going to skip the 1s, and I'm just going to type the 60 times 60 times 3.785. I think the last one is a 1, yep. Let me just check that. Was it 3.785. And now I'm going to press enter, and there I have it. And they want me to round to the nearest whole number. So I'm going with 2,520, I'm going to round up there, 25 quarts per second. 25, 25, 25, 25. So let's see what we get. So 25, 25 quarts per second. Fantastic. See, there's the setup. You'll notice that they color-coded it here. Meters cancels with meters. Liters cancels with liters. Gallons cancels with gallons. And then they did their conversion here for time at the end. So it doesn't matter what order you do it in. Let's try this one more time. Okay, this time our question is, an object is moving at a speed of 7 feet per 1 minute. And I want to express this speed in meters per second. So I'm just going to let that hang out down there so I remember what my goal is. And now I'm going to go grab some measurements from my reference sheet. But I always like to do time first because that's the easiest one for me. And I know I need minutes in the top. So what do I know about minutes that can get me to seconds? Well, for every 1 minute, that is 60 seconds. So there is my conversion for the time. Alright, now it's time to change feet to meters. So I'm going to look at my chart here. I'm looking for anything that has to do with feet. I see feet, I see feet, I see feet. Oh, here we go, right down there at the bottom. It's kind of tiny on my chart. You can see it a little bit larger on yours. 1 foot is 0.305 meters. So again, where do you want the 1 foot? Do you want it in the numerator or do you want it in the denominator? Well, we have it in the numerator, so that means we need it in the denominator. So that's how I set up my ratio. 1 foot, 0.305 meters. Well, this was a fast one. Not much to convert here. So now I have feet canceling with feet, and now all I need to do is get my calculator out. So I am going to just set up my fraction just like I see on my paper, because it's just so much faster that way. I'm going to leave off the timesing by 1 because I can. 3.305, and then 60 times 1, so it's just 60 in the denominator. And they want us to round to nearest hundredths, so 10 hundredths, that's 0.035. It's going to be 0.04. So it's 0.04, and don't forget, we have meters per second. Meters per second. So we're going to write 0.4, and they already wrote it for us here, so we don't need to. No, I messed up. It's 0.04. Yikes. Almost got that wrong. 0.04. Phew. Alright, one more maybe. Let's take a look. Water flows through a pipe at a rate of 12 cups every 5 hours. And we want to get that in gallons per week. So that's my goal. Alright, here we go. I always like to do my time first. So there are weeks. Ooh, okay. I don't know how many hours there are in a week, but I do know that there's 24 hours in one day. And I also know, there's my hours canceling. I also know that there are 7 days in a week. So 7 days, 1 week. So now I've got my week. So I'm done with the time, and now I have to go to the cups to gallons. So let's take a look at this chart. Make it a little bit bigger for a second. Cups to gallons. Oops, this is the wrong chart. This is the chart I want, so I'm going to take a quick screenshot. Okay, let's put it here so I can kind of work with it better. Alright, so here we go. Alright, so I need from cups to gallons. What do I have here? What do I see? I see cups. Anything else with cups? This is cups. Alright, so I have cups to ounces or cups to pints. Well, let's see what I know about gallons on this chart. I have gallons here, gallons in quarts. I have gallons in liters. Gotta find a way to get them to be in the same family of, I think I'm gonna go, this is a tough one, but I'm seeing here a connection with cups to pints, and then pints to quarts, and then quarts to gallons, right? Can it be done another way? Possibly, but I think I'm gonna take this path. So here we go. Let's get started with cups, because that's what I have here. Cups, so I need cups down below. And I'm going to go with 2 cups, make 1 pint. Shorten this down a little bit. And then that gives me a cross off for cups. Cups and cups. Now I need 2 pints. That's going to go in the denominator because I need my pints to cancel out. 2 pints is 1 quart. And now I'm going to use 4 quarts is 1 gallon. And 4 quarts, 1 gallon. So when I have my cross-offs here, the only dimensions still showing are week and gallons, and that's exactly what I said I wanted. So we have all of our rates here. All of our rates, we have it set up. Now all I need is my calculator. So here we go. again, I'm going to set up my fraction first. And let's see, my numerator is 12, 24, 7, and all the rest are 1s. So I really just need 12 times 24 times 7. And then my denominator is 5, 2, 2, and 4. So 5 times 2 times 2 times 4. My final answer is 126 divided by 5. They want it rounded to the nearest tenth, so I'm actually going to convert this. I can either do 126 divided by 5 myself, I could do that, or I can press the math button and say turn my fraction into a decimal. So take my answer and turn it into a decimal. It's 25.2, round to the nearest tenth. That's perfect. So we're going to write 25.2 in our response down here. All right, I think that's enough for the dimensional analysis. Let's take a look at literal equations. Most of you are pretty good at these, but remember, if you're solving for a, that means that we want to get a by itself, and so we need to get rid of this, and we need to get rid of that. But a is in a denominator, and that's not allowed. So I think the first thing I'm going to do is get rid of this, because that allows me to concentrate on just my fraction. So let's see, I've got here n, and I'm going to add h squared to both sides. And now I need to get rid of this a, and you get rid of a denominator by multiplying both sides completely by a. Okay, we're getting closer. So now we have a really long piece of math with my a, which is almost like getting worse before you get better. But now for our final step, and that's I can get a by itself by dividing by this entire huge quantity. And that is our final answer. 7 divided by n plus h squared. So I'm going to put that here. 7 fraction bar. You can use parentheses, you don't have to. N plus h. Shift 6 will get you to the power button. Alright, next problem. Again, I want to get a by itself. You could solve this, actually I'm going to solve this one a little bit different. Instead of moving the 9 first, you could also just multiply every term by a if you wanted, right? But I never really suggest creating more of the variable that you want to eliminate, but that is a correct math move. I'm not going to use it because I don't love it, but it is a correct math move. All right, let's multiply both sides by a. I'd like to write mine over here like that. That will give us 4d equals a times g plus 9, and now I can divide by that giant quantity, g plus 9. So 4d over g plus 9. Alright, I think you're getting the hang of those. Evaluating quadratic functions is just erasing and replacing. So carefully insert this number -5 into that variable x. So if you have negative x squared plus 9, you're going to insert the actual value, which is -5. Then you're going to pick up your calculator because you don't want to make a mistake, right? You don't want to make a mistake. So all of those negatives and parentheses, they're really important. So here we go. We're going to have a negative parentheses, -5. Outside of the parentheses is the square. Oops, sorry. Is the square. And then you have plus 9. So use your calculator. That's why you get it. -16. All right, same one with the next one. You erase and replace. Please make sure you're using your calculator properly. Linear versus exponential. All right, this one is always a multiple choice question on the Regents, so you really want to focus on understanding what this word linear means, and linear means a constant rate of change. The same exact value is added or subtracted each time. Okay, not that it's the same pattern, because you can have a timesing by 2 pattern, but that's a common ratio, not a common difference. So we want to concentrate on looking for something that is not a percentage. So that would make this one wrong. No percentages, no percentages, because a percentage is an amount that changes each time. So no percentages. So here we go. A flat fee, that's the initial value, and then the rate of change, 450 per mile. So we're going to select this one here. Again, next problem. Which one represents linear growth? Linear growth has to have a common difference, so it cannot be a percentage. Cannot be a percentage. All right, amusement park charges $5 to go on each of the rides, or snow was melting at a rate of 2.5 inches per hour. So this one here is a constant linear rate, so it's just $5 to go on per ride. The snow was melting at a rate of the snow is melting at a rate of 2.5 inches per hour. So that's melting means you're going down. The amount of snow is going down. And this one asks for growth. So be very careful that you're paying attention to the words, right? We're looking for growth. So it's $5 per ride. Which of the contexts below represents exponential decline or decay? Okay, so exponential growth is generally a percentage, or doubling, or tripling, or halving. So this one says decays, this one says grows, this one says descends, and this one says appreciates. So to appreciate means to go up, to grow means to go up. So it must be one of these two, because those are the only that are declining or decaying. This one has a percentage, this one has a constant rate. So for us, it's going to be the first one. Our radioactive compound decays at 8% per hour. All right, now we're going to compute some actual exponential functions using our exponential growth or decay formulas. This is something you might need to look up, but generally it is your starting amount. I feel like I should screenshot this. I'm going to move this. There we go. All right, so this is our exponential growth or decay formula. And so we need to understand that the amount that you're going to get depends on the principal value, right, the starting amount, the percentage rate of growth or decay, and the length of time. So let's fill in the values that we have. It starts at 430 grams, so that is the p-value. It decays by 27.4%, so it's going to be minusing, and don't forget to move the decimal in your percent. How much of the element is remaining after 19 minutes? So since it's per minute, this is the right conversion. So get your calculator out, and let's get started here with 430, parentheses 1 minus 0.274, and then an exponent of 19. And it says round to the nearest tenth of a gram, so it's going to be 0.98, so it's going to round up to 1.0, so 0.98, this is the tenths. So if this rounds me up, then I have to move that place value over 1. So we're going to put in 1.0. Okay, one more time. A town of a population of 2,000 and grows at 4.5% every year. What will be the population after 13 years? Round to the nearest whole number. So my starting value is 2,000. My growth is a plus, and my percentage is 0.045. And the time is 13. Time is 13. So I'm going to need here 2,000 parentheses 1 plus 0.045 raised up to the 13th power. Again, I think it said round to the nearest, whole number this time, 3544.3, that's 3544. Okay, last topic, graphing piecewise functions. Now remember, you're only going to graph certain sections of this function. That's why it's called a piecewise function. So as I'm making my tables here for 3x plus 15, I'll use my calculator, go to my y equals button, and I'm going to type 3x plus 15. And when I look at my table, I'm only going to plot from this number. I have to start at this number, -3. So I'm going to start at -3. So -3, 6, -3, and +6. Right? And let's see. All right, so click the line to delete it. There we go. Okay, so I have -3, 6, so that's up here. And then I need to hold my mouse down and click to another point. -3, 6, I'll do -6, -3. So -6, -3. There's my 2 points. Now this one here can be equal to, so that's solid. And this one here should keep going, should be an arrow. So I had to click it twice, because I can be anything less than -3. So I had to click it, this dot, I had to click any dot in this table. Now for my next one, y equals, I'm going to go back here and I'm going to type in my y equals button, -2x plus 7. And when I look at my table this time, I'm going to start at 2. So I'm going to start at 2, which is 3, and then I can be anything greater than that. So I'm going to go to the point 2, 3, click once, nothing will appear, but hold my mouse button down and then click away, go to 3, 1, or 4, -1, 3, 1, or I can even go to 4, -1. Okay. This inequality is a greater than sign. So it has to be an open circle. And I can be anything greater than that. So I can go down this table even farther. So this dot is not an endpoint. It should be an arrow. So I click it twice until I get that arrow. Let's do this one more time. Get your calculator out, go to the y equals button, type in your first function. It's x plus 4. Look at your table, and your table should only be from -3 to 0. So I'm going to look at -3, so -3, 1, and then to 0. So -3, 1, click, nothing will appear, hold your mouse down, and then go to 0, 4. Okay. Look carefully at the endpoints and whether these inequalities are telling you whether they should be open or closed. These should both be closed. So my first function is done. My first piece is done. Second function is -2x plus 7. And we look at our table, and it's 0 to 6. So I'm going to go, I have to start at 0, 7. And now I have to arrow down so I can see my next value. So 0, 7, that's my first point. 0, 7, click once, hold your mouse down, then go to 6, -5. Now let's determine our endpoints. The 0, 1 should be open, and the 6, 1 should be closed. And that is it. That's how you complete homework number 30.